Well, good evening, and welcome to Dome at Home, the Manitoba Museum's award-winning astronomy live planetarium online show thing. I'm your host, Scott Young, and it's great to be back for another episode of Dome at Home. Lots of people checking in on the chat. Do say hello. We like to turn this into a bit of a conversation as the night goes on. So if you have questions or you just want to say hi, let us know where you're watching from. That's all useful stuff. The more comments I get, the more I get paid. No, not actually, but then I have stuff to show my boss. All right, we have a full show today, and we've got a couple of segments that we don't run regularly, and one of them is a brand new segment inspired by events this week that we're going to start with. And let's see, our first, it doesn't have a cool title theme yet, like cool space stuff, but our first segment is stuff that's wrong. Yes, stuff that's wrong. You may know that not everything you see on the internet is correct, and that was brought home to me very, very directly this week. Oh, volume is low. Let me see what I can do about that. How about that? Is that the right knob? No, that's not the right knob. That's a little bit better right there. Check 1, 2. What if I eat the mic? Is that better? Okay, I think that's about as high as I can go. So hopefully you can hear me out there. Thanks, Phil, for letting me know. I started getting calls about meteors this week, and it's a little early. Of course, there's the annual Perseid meteor shower every year, and that is something that we always talk about. And I get a blog ready to go, and I get a press release ready to go, and send it out sort of the beginning of August. Well, this week, all the media started calling me last week of July, talking about the big meteor shower that's coming. And so it turns out that either the AI social media scrapers or actual people have gone through an astronomical almanac somewhere and have absorbed the dates of all of the different meteor showers. Now, there's some famous ones, and they're famous because average people can see them, but there are some of scientific interest but not public interest. For example, there's a meteor shower called the Alpha Capricornids, and it peaks yesterday, and it peaks with a grand total of less than 1 meteor per hour. Now, on any average night, you can go outside, and if it's dark, and if you pay attention, you'll see 2 or 3 meteors per hour, no problem. So that's not really a shower. It doesn't really add to the rates very much. It's something that's been identified as coming from an object, and so it's in the almanac, but it's not something that I've ever told anyone about before because it's not observable. However, either the people or I like to think that it's AI that have just gone through and absorbed all the encyclopedias of all the years, have found these dates, and they have found that if you put a post with really colorful meteor pictures on it, and you say something like Skywatch alert, and you say that's a rare, once in a generation, blah, blah, all these words together, people click on it. And so basically AI is making stuff up and putting it out there and trying to tell us that there are these big events going on. It's really disappointing. I'm not quite sure how to deal with it yet. I started doing interviews yesterday because there are actually this ad is one of them. There's 2 meteor showers that peaked yesterday. The Alpha Capricornids, 1 meteor per hour, and the South Delta Aquarids, which are actually a minor meteor shower that we have talked about before. On a good year, they can be like 15 or 20 meteors per hour. This year, they're more like 5 to 10 meteors per hour. So this rare, once in a generation, light up the sky, double meteor shower thing that is being touted on social media, you can expect something like 6 meteors per hour if you never look away from the sky for that whole hour. Don't blink, you might miss one. It's frustrating because when I send someone outside for an event, I want it to be something that they're going to experience, and it's going to be magical, and it's going to be wonderful, and it's going to change their lives, or at least they're going to enjoy it. At least they'll see it. But this is stuff that's just made up. So in desperation, I've added stuff that's wrong to the show lineup. And I imagine I'll have to run this pretty much every show to cover all of the the stuff that we see on social media. I'm not going to touch the supermoon. That's a whole different thing. I lost that battle. People like the supermoon, totally fine. I'm fine with that. It gets people out. The moon's actually there. No, they're never going to put a supermoon out and have you go out and there's no moon. So at least that's not a problem. So yeah, meteor showers. We will be talking about the Perseid meteor shower coming up a little bit later in August. If you see any meteors any other time during the summer, it's probably a fluke, because the meteor showers that are active, there's actually 11 meteor showers active right now, technically, each one producing, in some cases, less than 1 meteor per night, let alone 1 meteor per hour. So it's a little bit too much information kind of situation, I guess. All right. That's the only thing in the stuff that's wrong category today, though. So at least it's not taking up the whole show. Here's some stuff that's right. We opened some new planetarium shows, and I would like to tell you about them because they're really good. Wilfred Buck's Star Stories. Well, if you don't know who Wilfred Buck is, he's a Cree sky expert. He's been basically compiling the sky stories of the Ininahuac, the Cree people here in Manitoba and across sort of the prairies. And he's been involved in a whole bunch of different things. He finally got to do his own show. And this is basically, it's written by him, it's narrated by him. It's put together by a company out of Toronto, a film company that helped him with the technology. Wonderful show. Definitely recommend it. It's going to be running all summer. We're probably going to be running it at other times as well throughout the year, but it is definitely something that if you want to catch it, for sure you can catch it this summer. We also have our special kids show, which is Voyage of the Stars. This is actually pretty cute. When they say the title Voyage of the Stars, it just sounds like a generic planetarium kind of thing. Well, the stars are a shooting star and a starfish, and the show actually is sort of a fun and lighthearted but rigorous comparison of the trials and tribulations of exploring space versus exploring the oceans. Both very similar kinds of things you have to worry about, and also the amount of life in the ocean and what that might imply in other places in space where there are oceans. It's actually, I mean, it's aimed at kids because it's got cute characters and cute voices and things like that, but it's actually a really good show. And it's got some great real footage of undersea creatures. So imagine just using the planetarium as an aquarium and watching whales and octopus and all that kind of stuff swim around. Pretty cool. And finally, the Milky Way Live. This is kind of our summer take on the regular live planetarium show, the guided tour of the night sky that we do. I wrote this one as just using the Milky Way as sort of the feature. And so we tour the Milky Way as you can see it from here on Earth, but then we zoom into all the different sort of constituent parts of it and look at stars that are being born and stars that are ending their lives and all sorts of cool stuff. So that's a fun show, and it'll also get you all set up for any kind of summer stargazing you might want to do. It'll show you where all the constellations are, what's going on with the planets and all that kind of stuff. And, well, thanks, Rihanna, for chiming in. I appreciate that. Yeah, Rihanna runs the shows, and so she's had a lot of input into, especially Milky Way Live, but also the way we do the other shows as well. So yeah, it's a good summer. Sometimes we have shows where we take a different tone or whatever, and here there's a good range of shows for everybody. So if you get a chance, it's a great way to support this program, and it's a great way to support the planetarium because all of your admission fees basically help pay our salaries. So Rihanna and I thank you. All right, let's get to some of your pictures. And this is something that I'm pretty excited about. I love it when you guys send in your pictures, because first of all, it reminds me that people are out there doing astronomy. It was kind of a dearth for me in the last month or so. There haven't been a lot of clear nights between smoke and summer stuff going on and things like that. So the first one I got just before the show last week was from Craig, this great shot of the moon. He was out shooting birds, and the moon happened to be in the sky, as it is often during the daytime. And he just took a shot of it, and some really amazing detail. I'm not sure how well it shows up on the screen out there, but you've got sort of all the dark areas, the Maria here, and then you've got the Terminator. That's where the shadow line is. But over here, the walls of one of the big craters the walls are lit up, but the floor of the crater is still dark. So you have this sort of, it looks like a little glowing handle sticking out from the moon. And then down here at the bottom, you've got all these craters where the floors of the crater are in shadow, and you can see all the sort of 3D aspect of the moon because the light's coming in at that extreme angle. Great shot. Thanks a lot, Craig, for sending this in. And yeah, whatever cameras you have, try them out on the sky. Oh, Jennifer, your son was at the planetarium this afternoon. Nice. Oh, I was off in the afternoon because I was here working on the show. So if anybody does come down to the planetarium, doesn't hurt to ask for me. I'm usually in Monday to Friday, and usually not on the weekends. But if you let me know you're coming, I'll pop by. I love to meet all of our Dome at Home friends. Here's a shot by Krishna. Now, longtime viewers will know Krishna from down in Texas, and he's often chiming in the comments and things like that, and does a lot of stuff. This is a great shot of the Milky Way, and I think it's an aircraft moving across the sky there. It's a time exposure, and so during that time the plane moved along, and the little flashing lights sort of went along, but it adds a little bit of mystery to this great shot of the center part of the Milky Way. Right down in here is right about there is the is the center of the Milky Way, right in behind all that dust and everything, the big black hole at the center. So great shot, Krish. Thanks very much. And Krish also has a one of those smart telescopes, a Dwarf 3. It's a little box that basically you can just connect to it with your phone, and it tracks a thing in the sky and takes pictures. And so here we have a picture of the Eagle Nebula. Now Hubble took a picture of this, and it got on the cover of Time magazine as the pillars of creation. And that region is actually visible here in Krish's image, right down in the center here. It's a little bit smaller than the Hubble Space Telescope, amazingly enough, in terms of the size, but a really, really nice image with all of this hydrogen and then some of these dark dust pillars and things like that. Beautiful image. This is one of the highlight objects in the sky if you are doing any imaging, certainly. So it's definitely one to look at. Nice job, Krish. Thanks very much for sending that stuff in. Let me see. Before I move on to some other questions, we've got a couple of things. If James asked, do we need to book shows ahead of time, or can we just show up? Yes, you can get your tickets online in advance if you want, and then you can just walk right to the theater and give them that. That's kind of convenient right now because we've got all that construction going on at the museum, sort of closing off one of the entrances. So it does make it convenient if you have your tickets in advance. But also, if you just show up, you can just come in and go to the box office, get yourself some tickets. And if you're a member, you can also, all members get all the shows for free. So if you're a museum member, you get all that. All right. Oh, and Rihanna already answered that. Excellent. Okay. All right. I got some more pictures. And speaking of Rihanna, this is one of her shots. Rihanna also has a Dwarf 3. She's had it for, oh, geez, quite a while, I think. Rihanna has started doing a bunch of astro imaging and went from, relatively beginner to amazing results in about 15 minutes, it seems. This is a shot of the North American Nebula. This is high overhead in the summer, right over by the summer triangle. And it's called that because basically the region that we have in here, the region that we have in here, this is like the Gulf of Mexico. This is kind of Florida. And then this would be Mexico, and then it actually stretches way up out of the frame here, and you could have a whole nother picture of basically the northern part of it. Really nice shot. And then I sort of spoiled it there, but she did a shot where you can, with the processing, you can actually take the stars out of it and just focus on the non-star things. The computer can tell the difference. And so here's just the gas with all of the stars removed, and it's really kind of spellbinding. I mean, you look at this and you see a lot of stars with a bit of cloud, but you take those stars away and suddenly you can see all of this dark cloud in front of this bright cloud. This is all hydrogen where stars would be forming. Really, really beautiful shot. Now this was a 60-minute exposure, looks like, so a pretty long chunk of time, but that's the great thing about the smart telescope. You can just sort of set it up and it takes the pictures, and then you do all the work to sort of process it and bring out all these details. So nice job here, Rihanna. And I think we got one more of yours. Yeah, here's the Butterfly Nebula, a beautiful another one of my favorite objects in the sky. It's a planetary nebula. This is basically when the sun runs out of fuel, this is kind of what it'll look like. All the outer layers will just puff off in sort of big smoke rings of material. And then down in the very center, there's a tiny little white dwarf star that'll be the slowly cooling core of the sun. Won't happen for 5 billion years or so, but it's kind of nice to know that all that material will float back out into space and eventually go into the next generation of stars. This is this is with a different kind of telescope, the C-Star 50, but Rihanna has one of each, and I guess, do they image at the same time? You got them both going at the same time? I guess that cuts down on the amount of time you have to do, but we'll have to have Rihanna come on the show and chat a little bit about her experiences with these telescopes. And Krish, also, you've got the Dwarf 3. We were chatting off show, and he said he really likes the Dwarf 3. So I have sitting upstairs a loaner version of the C-Star 50 that I need to get out under the stars so that I can try it and get in on this whole smart telescope thing. Okay, we're going to move on here, and let me just check. I did want to point out that if you want to send us any of your images, you can do so through all the usual kinds of ways. Manitoba Museum, we're at Manitoba Museum on Facebook and YouTube. The best way to get them to me directly is space@manitobamuseum.ca. That's direct to my desk, and that can handle big attachments and things like that. So if you've got pictures, you've got drawings, you've got a story that of one of your observing experiences, I'd love to be able to share it with the groups here. And it's just nice encouragement, because sometimes, I don't get out observing as much as I like, so I can live gratuitously through you folks, and hopefully that's the same for the other folks in the audience. Ariana's saying, I set up both scopes side by side and set them on different targets. Oh yeah. I envision like a picnic table with like 6 of these telescopes all set up and going around the sky and stuff like that. We got to get that going, like a massive, tiny observatory. Okay, we're going to move on to a sometimes regular sequence that we call Connect the Dots. And this is where we sort of take a feature constellation and talk a little bit about it. I wanted to talk a little bit about the constellation of Lyra the Harp. Lyra is one of those constellations. It's just pure summer. It is got this basically the brightest star in the northern hemisphere of the sky, with the exception of the sun. And it is high overhead during summer nights, so it is really, really well placed. And it's got a couple of really cool objects inside. So we're going to take a look at Lyra the Harp. So the ancient Greeks, in their infinite wisdom, decided that this area of the sky would be named in honor of the lyre, which is kind of like a harp. Not exactly, but, and it was supposedly the lyre of Orpheus. And Orpheus was the god of music and things like that. So kind of a musical constellation. I don't really see how you get that picture out of these stars. To me, this looks like a fish. Here's the nose of the fish down here, and this is like the body, and then the little triangle tail. That's how I used to draw a fish as a kid. Actually, it's still how I draw a fish pretty much. And Vega is actually the star right at the tail there. So this is the brightest star in the northern part of the sky. But if I took those lines away, I mean, there's a bunch of stars over here that are kind of the same brightness, and all around here, you could make up whatever you want. But to be honest, this little parallelogram and a triangle does stand out pretty well in the sky. These are all pretty bright stars. I've seen them from downtown right outside the museum at night. Vega, like I say, is super bright. It's one of the 3 stars in the summer triangle, the brightest one. So it's a good signpost. Now, the great thing about Lyra is you can pretty much see the whole constellation in binoculars. If you take a regular pair of binoculars and just point them up at Vega, the bright star Alpha Lyrae here, you get pretty much half the constellation in one field of view, and then if you sweep down, you get the other half of the constellation. So it's a constellation that is very easy to sort of get a close-up view of. Often people are using telescopes and binoculars and they'll say, I'd like to see the Big Dipper, or I'd like to see some other constellation. Well, those are usually just way too big to fit into a field of view, but Lyra is almost big enough, or almost small enough, that you could fit it all into one. Now, these labels all over the place here, these are created by Stellarium, our favorite free planetarium program. And each one of these is a little double star. And one of the neat things about Lyra is that it's got a bunch of double stars in it. Now, double stars are given that name because when you look at them in a telescope, it looks like there's two stars. It turns out that some of those are just two stars that happen to be at different distances, and they just happen to be in the same line of sight. Whereas in other cases, they're actually two stars orbiting around each other, a multiple star system. So, you know, for you Star Wars fans, like Tatooine with the two suns setting and things like that, there are places like that. Some of them are more than two stars. For example, in the triangle of Lyra over here, off on this side, we've got what looks like a double star. These are called Epsilon 1 and Epsilon 2 Lyrae, you know, again, Greeks, gotta have good names. But each of those stars is actually a pair of stars going around each other. So there you'd have sort of four stars in your view. And then farther down in the body of the fish, or the body of the harp, I guess, Delta 1 and Delta 2 Lyrae, these two here, they're not actually connected to each other. They're just in the line of sight, but they sure look like a nice little double star. And it's a good test for your vision to go and, you know, if you can see that that's actually two stars, you have pretty good vision. And if you can see that you have two stars in binoculars, you have pretty good binoculars. So definitely a couple of neat things to look for. In a telescope, a lot of these double stars actually show all sorts of different colors. Stars, of course, are not all just white, but you've got, you know, yellows and oranges and reds and blues. And because of the contrast effects and the way our eyes work, you can actually get some really striking colors where you'll get stars that look golden and purple, for example, right next to each other. So that's a sort of aspect of astronomy that a lot of people don't focus on, but it's a pretty cool thing to look for. And down at the bottom, or I guess the front of the fish head, there are a couple of stars down at the bottom here. This one, Beta Lyrae, is what's called a variable star. It's a star that actually gets bigger and smaller over a fairly regular period, over about a half a day or so. And so it gets brighter and fainter. Now, not by a whole lot. It's not like you're going to see this blinding light in the sky and then it fades away. But it does vary enough that if you were to watch it carefully and compare it to other stars, you can actually see that in binoculars or a telescope. And those kinds of things, variable stars, are very common throughout the sky. We're lucky that the sun is not a variable star, because if the sun got brighter and fainter or larger and smaller on a regular period, we wouldn't be here. The fact that the sun is so stable over long periods of time has really provided us the opportunity to be here. Right between those two stars is a cool little thing, and this goes beyond sort of the binocular kind of thing. But in binoculars, you can sort of see where it is. There's this little green dot called M57. If you pointed a small telescope there, you would see a little smoke ring in space. And this is kind of like that image of Rhianna's that we showed, the butterfly nebula, except in this case, the smoke ring is seen sort of face on. So instead of being sideways and looking kind of like the side of a donut, we're looking down the whole of the donut. This is a view in a small telescope, and this is one of the highlights of the sky, the Ring Nebula, it's called. And it's probably one of my favorite objects as well. It's just a beautiful little thing to see in a telescope. You do need a telescope to see it, but it's a pretty nice object. Now here I've moved my binocular field off of Lyra. This is just the very tip of the nose of the fish. So the rest of Lyra is off the screen to the top. And if you were to follow from Beta, that variable star, past the Ring Nebula and then past the other star here, and keep going, you kind of wind up, well, near a little thing in the sky here. Let's center on that. You might see a little fuzzy spot in the center of the screen there. This is pretty hard to see in binoculars. A small telescope, you should be able to see it. And if you've got a smart telescope, you can certainly image it. That is what's called a globular star cluster. It's a cluster of about 100,000 stars all packed into a big ball that are all orbiting each other. And that is some of the oldest stars that you can easily see. So it is the kind of objects that a lot of people with telescopes will go out and look for. To the eye, in a small telescope or a small binoculars, just detecting it is sort of the challenge, and you'd need a dark sky, to be honest. But in a small telescope, you get a view kind of like this, and it's a nice little view of all those little stars sort of all packed in around the center and then fading out to the edges. And then all of these other stars here are in the foreground. The globular star cluster is actually outside our galaxy, outside the spiral arms of the galaxy, sort of up above it, and off in sort of deep space. So that's one of the more distant parts of our galaxy. Now, I was chatting with Rihanna, was it just yesterday, I think? And we said, hey, you don't have any pictures of the Ring Nebula or M56, this globular cluster in Lyra. And she said, no, but I was just thinking about that. We should. So anyway, Rihanna went out and shot these like last night. So this is her C-Star 50 here. There's the Ring Nebula with 90 minutes of exposure. So it takes I think 10-second exposures and then keeps adding them up, and you get this beautiful view. Look at the colors there. There's like this greenish sort of center area, and then the yellow, and then around the edges there's this beautiful red. You can just see on my original image the tiny little white dwarf star left in the very center. I'm not sure if you can see that on the broadcast or not, but great shot here. And then M56, there's the little globular cluster off in the distance. And this was a 2-hour exposure. I didn't realize at first how much fainter this object would be. But these are both what are called M objects or Messier objects. There's a list of 110 objects that are kind of like the greatest hits in the sky for people with telescopes. They were things that Charles Messier, back in the 1700s, a French comet hunter, he would look around the sky for comets, and if you found a comet, you got paid and you got famous. But he'd find these other little fuzzy things that kind of looked like comets in his little telescope, but they didn't move, so they weren't comets. So he kept a list of them so he wouldn't get fooled again. And now we know him for his list of things he didn't care about. So the Messier list is kind of a great target of things to look for. So if you've got a telescope and it's got one of those lists of objects to look for, anything that starts with M is probably going to be pretty cool. Of course, there's lots of other cool things in the sky, but we'll take a look at some of that stuff in just a little bit here. All right, I want to check the chat here. Let's see. Oh, Phil, you were at Birds Hill before Folk Fest, right? Okay. There's a guy that brings his telescope to Folk Fest, and usually he's up on Pope's Hill in the campground at about 3 or 4 in the morning when the party is just starting to wind down. He shows people Saturn because that's what was in the sky. I didn't get out there this year for that, but I did see some of the Folk Fest. Yeah, the Ring Nebula is one of my favorites. Cool stuff. Okay, let me see here. How are we doing for time? We're doing not too bad, so I think it is time then for
Cool Space Stuff!
Nice to hear Mike's voice in that stinger. For those of you that remember Mike from the first season of the show, our announcer and chat moderator, he's on his way up north right now. He does Students on Ice every year, and he's going to be up there. They're getting on a ship and going up to Greenland and taking a bunch of students out to experience the North, things like that. So we wish him safe travels as he explores the Arctic. All right. So there's a bunch of cool space stuff. In fact, there was so much that I had to leave some of it out because it wasn't quite as cool as the rest of it. So NASA has been having some trouble lately. There's some arguments over its funding. There are some differences of vision, shall we say, in much of the United States right now. So I was surprised to see that these, the tracer probes were launched into space. They're twin satellites, and they go over the Earth, and they take consecutive images of the same spot. So rather than taking a picture of, say, Winnipeg, and then 90 minutes later when they come back around, they can take another picture, here you've got a picture and then another picture a few minutes later. And so it allows you to do things like make a 3D image of the of the view, or to see what kind of very fast changes are happening in cases of things like, say, a hurricane or a volcanic eruption where things can change really, really quickly. So that'll be kind of cool. And they're going to study also specifically the space weather. Sorry, I conflated a couple of satellites here. These ones are to study the space weather, which is, of course, all the stuff coming in from the sun and affecting everything from radio communications to northern lights to things like that. So this launched just, I guess, about a week ago, and we're looking forward to seeing some of the results from that. And there's a crew that's supposed to be heading up to the space station. They've been trying to get up there every day now for about a week. There was a bunch of problems with the rocket. The SpaceX Falcon 9 had a leak when it landed, and then they had to do a bunch of stuff for that. Today they were supposed to go, and then it was canceled because of weather in Ireland. Because as they go up, they have to have a couple of places where if something goes wrong, they can come down and land. And one of them's in Ireland, and there was all sorts of storms. And the day before that, it was the storms in Newfoundland that prevented the launch. So there's a bunch of stuff going on there that makes it complicated to get these folks up, but they will be heading up to the International Space Station. A reminder, we've got 6 people living up on the space station right now, and there's 3 people aboard the Tianhe Chinese space station as well. So 9 folks in orbit right now. And let's see. This is the one I was talking about with looking at natural disasters. This is a joint mission between the United States and India, and it's this gigantic fold-out origami satellite dish that is a radar. And the idea is it will point down at the Earth, and it will do very high-resolution radar imaging of things like volcanoes and hurricanes and all those kinds of things, and provide really high-resolution imagery of these big sort of natural disaster kinds of things. I was surprised to see both of these missions continue because I guess they were already ready to go. They were ready for launch, but there was a lot of the things that are being slated for cancellation at NASA have to do with observing the environment or the Earth or things like that. So it's nice to see that these missions weren't, curtailed and shut down when they were already ready to go. This is kind of cool. We talked about the Ring Nebula. Stars like the sun, when they run out of fuel, they puff off their outer layers, they turn into a white dwarf, they slowly fade away. Other stars go out with a bang. A big star can explode in a supernova explosion, the biggest explosions in the universe. And when they explode, they give off roughly as much energy as the rest of the entire galaxy that they're in. Well, right now, there is a supernova visible in a small telescope in the spiral galaxy with the wonderfully poetic name of NGC 7331, also called the Deer Lick Galaxy. I'm not quite sure where that name comes from. Maybe James, you might know, but it's like a little mini Andromeda galaxy, it kind of looks like, and surrounding it, there's a whole bunch of these other little galaxies around it. Well, right near the core, there is a supernova. That star was not there last month. And it's not one of these other stars that are just in the foreground from our own galaxy. It's one of the stars of the galaxy itself, of NGC 7331, that blew up. And so over the next month or so, we'll see it slowly fade away. And this is a picture from the GOTO telescope, which is a pretty good-sized telescope. It's basically designed to look for changing things in the sky. So it's a pretty handy telescope to have if you're looking at supernova, because these actually happen a lot in all the different galaxies. Like if you think about how many galaxies there are, billions and billions and billions, one of these happens probably once every 100 years in a given galaxy. But if you watch 100 galaxies, you'll see one a year. And we watch thousands of galaxies now. So there's actually a lot of them going on. It used to be supernova 1987A, and then 1987B, 1987C, and that would be kind of it, because we were only finding a few of them. Well, now 2025, we're up to 3 letters. It's like an Ontario license plate now with the qualifications of how many things we're finding here. So lots and lots of supernovas. I managed to get a picture of it myself. It doesn't show up great in this picture because this is shot through all of the smoke and haze, but this is with my substantially smaller than the GOTO telescope observatory, and you can just see the little supernova indicated there. It's kind of cool to see that. And going to follow that for the next little while. So definitely visible in small telescopes if you're imaging, and if you've got something like a, I don't know, a 6 or an 8-inch telescope that you're using visually, if you go on a dark night and you find NGC 7331, it's over in Pegasus. It is, I would think that you could see it with the unaided eye as a little tiny star right near the center. So if you do get a chance to see it visually, let me know. I'd love to see that. Here's another cool thing. You might remember the asteroid that was going to hit the Earth. It was 2024 YR4, and they discovered it, and there was like a 3% chance it was going to hit the Earth. And people panicked for like 2 weeks until we got more observations of it and realized, no, now that we know its path more precisely, it's going to miss the Earth in 2032. But as the path was being refined and it was moving farther and farther away from the Earth, it was moving closer and closer to the moon. And there's now a 4% chance that this asteroid will hit the moon on December 22nd, 2032. Now, we don't have to worry, because if it hits the moon, it will make a crater. And I don't know if you've seen the moon before, but there's lots of craters there. It's not a big deal. It's not going to knock the moon out of its orbit. It's not going to shower us with giant rocks or things like that. However, it might shower us with moon dust. It turns out that some of the scientists over at Western University in Ontario did some research and some supercomputer simulations, and they figured out, okay, where exactly is it going to hit, and what would that do? We kind of know that this object is a certain size. We know it's coming in at a certain speed. Depending on where it hits, where will all the debris go? And so they did all these simulations. It'll hit somewhere along this line. So it's going to hit the southern hemisphere of the moon. And the farther to the right that it hits, the more likely it is that we will get the pieces will actually leave the moon and then eventually make their way to Earth. Now, the pieces will be smaller than a meter across, all the way down to the size of dust. Most of it will be dust. So we're not worried about, rocks falling out of the sky. But imagine 100 million tons of moon dust falling into the Earth's atmosphere one night, and imagine the meteor shower that will cause. So they did this study. And here's a complicated graph, but basically it turns out that depending on where it hits, there'll be a big cloud of material that will reach the Earth between 3 and 4 days after impact. And that will probably generate a bright meteor shower with some bright ones and some faint ones. They won't know the exact mix. It'll be one of those things that you'll have to see what happens. A number of people will probably be doing family type things 3 days after December 22nd, 2032. I know that there's a few holidays at that time of the year, so that would be kind of an interesting event. Now, it turns out if the things hit farther to the left of the moon, the particles actually take longer to get to the Earth. They might take 20 days or they might take 30 days to get there. And in each case, there's sort of a repeat of these particles, because of as they sort of spiral out of the moon's orbit and spiral into the Earth's gravity and so on, they sort of do that in clumps. Now, this is not 100% what will happen, because it's only a 4% chance that the impact even happens in the first place. In 2028, that asteroid comes around again on this side of the sun. We can do some more observations. We can refine its position even more, and then we'll know, basically in 2028, this chance will either go from 4% down to 0, like it did for the Earth, or it'll go from 4% up to 100%, because we will have enough data at that point to be able to say for sure whether this thing's going to hit or not. If it is, basically I'll be watching that day to see what that result is, because if it is going to hit, that's the kind of thing that you don't want to miss. First of all, seeing an impact on the moon, because here's the view from Winnipeg at impact time. This is the western horizon. The moon is about 15 degrees up, and you'll be able to sit there with your binoculars and watch something hit the moon and explode. And you'll either see a bright flash on the light side of the moon, or you'll see a bright flash on the dark side of the moon, which would be even cooler. This is happens at about 10 in the morning. So, and then we would have a 3-day wait for the big meteor shower. So I know that's a lot, like that's 3 years away before we even are going to know if this is going to happen or not, but still, it's pretty cool. There is one recorded instance in like the 1500s of a monk that witnessed an impact on the moon, or we think was an impact on the moon. It looked like there was a flash and then there was a cloud around the moon and so on. And there have been a few other ones seen since then with usually someone's taking pictures of the moon or video of the moon and happens to catch just a little flash that goes off. But we've never seen it in advance. It's never been predicted in advance. So this would be cool. And yeah, Phil, it looks like about right now, I think it's 4.3% chance that it's going to hit the moon. Still not very likely, but we'll see in 2028 when the next positions come in. So that is going to be quite the day, quite the Christmas holiday if we get a moon dust meteor shower, because how often does that happen, right? Okay, let me see here. I want to check the chat to see if we have any other questions. Looks like we do not. Okay. Oh, so I wanted to get back to the meteor showers. The Alpha Capricornids and the Delta Aquariids and all those ones, don't worry about them. They're non-observable. But the Perseid meteor shower is a regular highlight of August. Here's the thing. When I started observing, I had a lot of problems observing the Perseids because meteor showers are always best after midnight. In fact, they're always best just before dawn. Like 4 in the morning is the best time to see lots of meteors. And I never stay up late. And I never go to bed early enough so that I can get up early. So I was always watching at off times. And then I was also watching from my backyard or something like that. So there's some light pollution around. And then if the moon is up, that makes it harder to see meteors too. And then I don't have a great attention span, so I wasn't always looking at the sky, and I'd look away to talk to somebody, and then everybody would go, "Oh," and point behind me, and I would have missed it. So I get a lot of that. I haven't had great luck with meteor showers myself. But if you go at the right time, you increase your chances dramatically. Well, here's the right time. We're going to take a look at the sky using our friend Stellarium here. Let's pop over here. And here is, we're going to set this for the night of August 11th. Now, August 11th, the moon is up in the sky. In fact, we're very close to a full moon. So that does not, we're a little bit past full, I guess, but it's a pretty bright moon. So that is going to kill 2/3 of the meteors this year around. If next year, I think the moon is not in the sky, and so we'll have a much better view. But for this year, it's not the best because you've got that moon in the sky. Stellarium actually has all these meteor showers listed in it. You can turn them on, and like here's the northern Iota Aquariids. Let's see. It looks like it's going to have a rate of 0. Good. And then the Alpha Capricornids, current local hourly rate 0. Okay, great. There's the Southern Delta Aquariids, local hourly rate 0. See, it does the calculations for you, because those numbers that they list for meteor showers, that's if you were in the part of the world where the meteor showers center was right over your head. So for the Southern Delta Aquariids, you'd have to be somewhere, let's see, you'd have to be, in the tropics below the equator to get that position. We don't live there. So it does the math and figures out, well, we can only see a certain percentage of that hemisphere, so how many will that do? And it'll reduce it for your light pollution and things like that. So yeah, here, the Southern Delta Aquariids, the current zenithal hourly rate, ZHR, is only 2, and the local hourly rate, 0. However, let's go over to the Perseids. The Perseids are the old faithful of meteor showers in general. Where'd you go? There you are, Perseids. And here we are at 11 o'clock at night on August 11th, and the local hourly rate, not accounting for the moon, is 34. So if we take away 2/3 of that, 10 meteors an hour at 11 o'clock on the 11th. If we go a couple more hours into the evening, the rate has gone up to 48. So let's see, 2/3 of that is like 16 or something like that. If we go to 3 in the morning, the local rate has gone up to 64. and then you take away for the moon. So we're getting, better and better as the night goes on, because the radiance, the place where the meteors are coming from, is rising higher in our sky. And so we can see more of the meteors that are being created. They're still happening. It's just that some of them are happening below our horizon, or some of them are happening where we just can't see them. And if we go just before dawn here, we actually get up to a local hourly rate of 77 meteors per hour. This is early in the morning of August the 12th, which is, I think, a Tuesday. So 2/3 of that, we're talking probably 25 meteors an hour. That's not bad. That's one every 2 minutes. With the moon being in the way, that's not too bad at all. And in fact, the moon is kind of on the opposite part of the sky, so maybe it'll be even a little better than that. Maybe 30 meters, maybe 35. And also, coming up in the morning sky, on the same morning as the peak of the Perseids, we have a planetary alignment between Jupiter and Venus. Venus is the brighter one at the bottom, and then Jupiter is the fainter one at top. And basically, Venus has been moving down to the left, and Jupiter is slowly moving up to the right. And on the same morning that the Perseids peak, that's when the two of them pass each other. They'll be less than a degree apart. You'll be able to see them both in your same wide field telescope point of view, for certain in binoculars. And to the unaided eye, it'll look like two stars like right next to each other. I'm going to get lots of UFO calls the next morning, because people are going to get up to watch the Perseids. They're going to see this. They're going to freak out. And they're not going to know what it is. So it's going to be kind of an interesting day that next day. But lots of things happening on the night of August 11th and 12th. It's just too bad it wasn't a weekend, because then I wouldn't have to go to work the next morning. But alas, happens during the week. But that's what you got to do sometimes, is just deal with whatever Mother Nature gives you. Now, if that morning doesn't work for you, the morning before actually provides not a terrible view of the Perseids. The morning before, the local rate is still 50. So that's, you cut that down by 2/3, so it's maybe 15 or 20. So it's still a pretty good expectation. If you go the morning, the night of the 10th, the morning of the 11th of August, you get something like probably, we'll say 15 or 20 meteors per hour, one every 4 minutes or so, maybe a few more than that. That moon is the real culprit this year around. Now, coming up, my favorite meteor shower, the Geminids, December 13th. A little harder to sit out in a field all night in December here in Manitoba than it is in August, but well worth it. First of all, you get many more hours of darkness, and the Geminids are the best meteor shower of the year. So that'll have to be something that is, put it in your plans now, and figure it out about needing some time off. I got some stuff here in our chat. Let me just go back and check out what we got. Hey, Brian, nice to see you. Yeah, so the Starlink satellites, China's building their own. Actually, a couple of other countries are building their own. Do the astronauts fly through the orbit of these networks, or are these networks far above the orbits of the space station? That's a great question. And do these space organizations talk to one another? All very good questions. Space is big, but the parts of space that everybody wants to use, the parts near Earth, is not that big, and it's getting full, especially with these internet satellites and things like that. But there isn't really an international regulatory body that's governing this, and that's part of the problem. The law has not caught up with the technology when it comes to space exploration, and when it was only governments that could launch stuff into space, it wasn't that big of a deal, because governments tend to do things relatively slowly, and they also tend to think about broader implications. Not always, but there are people in the government whose job it is to deal with satellite crashes, just like there are people there who are building satellites. Well, once you get a private company involved, they don't have to deal with satellite crashes. That's somebody else's problem. So they can just build as many satellites as they want and send them up there, because no one said they couldn't. And that's kind of where we are right now. It's a little bit of Wild West. I like to think that we will find out that there will be some common sense applied, and that companies will start to mitigate the number of things they put up there. Eventually, it gets so crowded that if you get one collision, well, a collision breaks a satellite into 10,000 pieces. Each of those pieces is now flying off into space and can do damage as well. And you can wind up with big problems. In fact, going back to the moon impact in 2032, that's actually one of the concerns, is that if you suddenly have all of these little pieces of dust and rock coming into the atmosphere, and before they get to the atmosphere, they go through the satellite belts. So all of these satellites, they're designed to handle minor impacts, but they might get something like 10 years of exposure to micrometeorites all in one day. So we're not sure what will happen. Maybe that will clean out orbit, and we'll have to start fresh. I don't know. It's definitely a problem, and it's something that not a lot of the companies involved are really dealing with. They're pretty much just going ahead and not worrying about the problems, which is a bit of a problem. James, the Deerlick Group. Really? Okay. So in the comments, James has pointed out that this guy calls this galaxy NGC 7331 the Deerlick Group because he had a really good night of viewing it at Deerlick Gap in a place. So he basically named it after the place he happened to be at when he was looking at it. That's stupid. Sorry. I mean, it's a galaxy. It's in the sky for everyone, and you name it. It's like naming it. I'm going to name it, after my cat or something. Anyway, that's disappointing. I thought it would have a story that was more sort of astronomically oriented or something. Anyway, what can you do? And James is pointing out that August 12th might be a great day for those of you that have personal days or vacation days to just take that day off. Because yes, if it's clear, it'll be a good night to be certainly up in that early morning hours. I don't think I'll stay up all night for the Perseids. I think I'll probably set the alarm and get up at about 3 a.m. And then I will be able to, see the best part of the meteor shower, and then see Jupiter and Venus rise in conjunction and have a good night like that. And if it's not the peak night, I'll go the night before or the night after, depending on what the clouds are. Jennifer asks, how is George? George is doing pretty good. He got into an altercation with one of the neighbor cats. George goes outside on a leash, but some of the neighbors just let their cats run free, and they got into a little bit of a disagreement over whose yard this was. George won, but he got a little scratch, so he's been nursing that for a couple of days. But you should see the other cat. No, just kidding. It's disappointing sometimes that I try and do the right thing and have him not rampage through the neighborhood killing birds or things like that, and then he gets ambushed in his own yard. But he's doing good, and actually he's sleeping just over there. You can't really see, but all right. Let me see here. The last thing I want to show you is, of course, a reminder. You can send us stuff at space@manitobamuseum.ca. That's a great place to reach us, and we always like to be able to see what you're doing. And if you're going to be coming down to the planetarium, let me know through that address as well, and I'll come out and say hi if I'm around. All of the folks that sent in images today and everything, thank you very much. The show is a big part of being able to feature your images is a big part of the show. And I really like to be able to do that. Thank you all for joining us. And hopefully we will see you next show, the last Thursday in August. And there we will be taking a look at, what will we be taking a look at? I think that's the one where we're doing camping. How to pack for astronomy. Anyway, yes, I think that's what that is. All right. Thank you all. Have a great evening. It's going to be clear tonight here in Winnipeg, so I'm not sure that I'll go observing necessarily, but I might try that sea star in the backyard and just see if I can get it going. Have a great night, and we will see you all on the next show.